In this video, we're going to find resonant frequency for the given circuit. So to find the resonant frequency, all I need to do is find the Z total of this given circuit and make the imaginary quantity equal to 0. So before doing that, we need to convert the given circuit elements into frequency domain. So 100 ohms is okay. It's going to be 100 ohms. This is j omega 80 milli ohm, and this is 1 over j omega 0.5 micro. So always 1 over j omega, just leave it 1 over j omega. Do not write this as minus j over omega. I mean, this is true, but at the same time it's going to mess up lots of our calculations. So do not separate j and omega, keep the j and omega together. So here all I need to do is find the Z total and the real part and imaginary part, make the imaginary part equal to 0. So we should be good to go. So here 1 over j omega 0.5 micro becomes, micro is nothing but 10 to the power of 6 when it goes to the numerator, and 1 over 0.5 becomes 2 times 10 to the power of 6 over j omega. Now 100 plus j 80 omega times 10 to the power of minus 3 milli is nothing but 10 to the power of minus 3 parallel with 2 times 10 to the power of 6 over j omega. Now they're in parallel, so multiply in the numerator, add in the denominator. This is what we're going to have. Now in the denominator, to eliminate the j omega in the denominator of both numerator and denominator of the Z total here, all I did the LCM for the denominator and then eliminated the j omega. Now here, this is what my Z total is. I end up with Z total equal to this much. Now here, to separate the imaginary quantity, make sure there is no j term in the denominators. But I have j 100 omega, so I need to eliminate the j term in the denominator. So to eliminate the j term in the denominator, all we need to do is I need to multiply the complex conjugate, take the complex conjugate of the denominator and make it multiply and divide. So that's what I did here. So when I multiply that in the denominator, I will end up with looks like a plus b, and this look like a minus b. So it's going to be a square minus b square. So that's what I have in the denominator. Numerator, when I multiply, I do not care about the real parts, so I'm going to leave the real parts as it is. Just take the imaginary I'm not going to multiply the real parts, just leave them. So here 200 multiplied with 2, that's the real part, just leave it as it is. 200 times minus 80, that's the real part, just leave it as it is. 200 times minus j 100 omega, that's imaginary, so I wrote it down. It's minus j 200 times 10 to the power of 8 omega. And then same thing, this is imaginary times real, that's going to be imaginary. So 160 times 2, j 3200. This is 10 to the power of 3, 10 to the power of 6, so 10 to the power of 9. So you will end up with basically j 320 times 10 to the power of 9 omega, but I wrote it as j 3200 times 10 to the power of 8 because the previous one is 10 to the power of 8. And then the last term is when I multiply j 160 omega times minus 80 times 10 to the power of minus 3 omega square, this is what we end up with. The last term is real part, so I'm going to leave it. Now there is no imaginary part in the denominator, so I'm good. Now I'm going to make the j part equal to 0. So this, all these three quantities divided by this must be equal to 0. So now denominator is going to move to the other side and it will become 0. So now I have omega naught is common in all three. I'm going to pull out the omega naught. Omega naught becomes 0. Omega naught square is nothing but, so 3200 minus 200, which is 3000 times 10 to the power of 8. This is minus 12,800 omega naught square. So omega naught square equal to 3000 divided by 128, 12,800 So I'll end up with omega naught square equal to 23.43 times 10 to the power of 6. Omega naught equal to plus or minus 4.84 kilo radians per second. Thank you very much.